Hello everyone, welcome back to my YouTube channel. I am Dr. Injamamul Haque, currently working as assistant professor at the Department of Mathematics, School of Computer Science and AI, SR University, Warangal. In today's lecture, we are going to discuss a very important concept in statistics, hypothesis testing for small samples, especially focusing on the t-test. This topic is extremely useful in research, data analysis, machine learning, and the real world decision making. By the end of this video, you will clearly understand what is t-test, when to use it, how to solve the problem step by step, and how to interpret the result correctly. So let's get started. Now, first, let us recall the hypothesis testing. So, let us understand what is hypothesis testing. In a simple term, hypothesis testing is a statistical method which is used to make the decision using the data. We start with a claim and then we test whether the data support that claim or not. There already we have discussed about that. There are two types of hypotheses. One is null hypothesis, is this represent the default assumption. For example, there is no difference or the mean is equal to the given value. Alternative hypothesis, this represent what we want to test. In example, there is a difference or the mean is not equal. So we also use the something called the level of significance, and we have denoted it as a alpha. Usually we taken the value of alpha as a 5%, as a 0.05, and 1% 0.01. This tell us how to strict our test is. So now the question is what? Why do we use the t-test? Okay. So we use the t-test when the sample size is small. When the sample size is small, that is n is strictly less than 30, population standard deviation is unknown, and data is approximately normally distributed instead of population standard deviation. We use the sample standard deviation as the t-test is based on the distribution which is wider than the normal distribution and account for small sample uncertainty. So let us start for the t-test for a single mean, right? This test check whether the sample mean is significantly different from the given population means or not, right? So first we'll take the assumption. So now let us take the assumption for t-test for the single mean. The sample is drawn from a normally distribution population, right? The sample is random and independent. The population variance is unknown and estimated from the sample, right? So you can say that this is the assumption. This is the assumption. These are the assumptions. The sample is drawn from the normally distributed population. Sample is random and independent. The population variance is unknown and estimated from the samples, right? So these are the assumptions. About now we discuss about the formulation or determination of the hypothesis. As we have discussed in the previous lecture, similarly, first we discuss the null hypothesis. We will determine the null hypothesis, and we will take the null hypothesis as a mu equal to the mu naught. Okay, simple mean equal hypothesized mean. Then we will take the alternative hypothesis, that is mu1 mu not equal to the mu naught. Okay, for the two tail test, for one tail test, that is right tail or left tail, we will take the mu is strictly greater than mu naught or mu is strictly less than mu naught, right? So we will take the alternative hypothesis like this one. So what things have to do? First we will formalize the hypothesis, right? And this hypothesis we will choose the null hypothesis, then we will choose the alternative hypothesis, and based on this we can determine the two tail test or one tail test, right? Already we have discussed about that things in the previous video. So now we discuss about the test statistic formula for one sample when the sample size is less than 30, right? So we will write the test statistic under h naught equal t equal to x bar minus mu naught by s by square root of n. So x bar equal to what? Sample mean. Mu naught equal to what? Population mean. S is equal to the what? Sample standard deviation. N is the sample size, and this would be always less than 30, and degree of freedom n minus 1. Then we will find the critical value from the t distribution table. Yes. So what is the step? In step 1 we will determine the hypothesis. Then in the second step we will find the t statistics. In the third step we will find the critical value from t distribution table, right? Later also we will present here the t distribution table. Okay, so in the step 1 we will find what? Step 1, determine hypothesis, determine the hypothesis. In step 2 we will find the t calculative or t statistics, or you can say that t statistics, right? Then we will find in step 3rd we will find the value, find t alpha, or you can say that critical value of t from t distribution table, right? Then we will determine, then what things we will determine? If mode of t calculative value is less than t alpha, it will what? It will accept h naught, right? If t calculative value is greater than t alpha, it will reject it will reject h naught. Okay, so these things have to keep in your mind to finding the test statistic for simple mean of a small size, right? So now let's move to important concept, testing difference between the two means for the small sample size. This is called the independent sample test. We compare the two group hypothesis. First we will take the hypothesis as what? We will construct the hypothesis. For this one, let test for the difference of two mean. We will take, let x bar and y bar be the two means of two independent independent sample of size n1 and n2, right? Drawn from two normal population. Okay, having having means mu1 and mu2. Okay, so now we will discuss about the procedure for testing the equality of mean of two normal population. Okay, so what is the formula? So first we will, what things have to do? We will construct the hypothesis, null hypothesis. Null hypothesis, what is that? H naught, this will be mu1 equal to mu2. So what will be the alternative hypothesis? Alternative hypothesis will be what? In this situation, alternative hypothesis h1, this should be equal to what? Mu1 not equal to mu2 for two tail test, and this is mu1 greater than mu2 for one tail, and or this is mu1 less than mu2 for also for one tail, and first one is called right tail, second one is called left tail test, right? So this is all about the what? Hypothesis. So first we will determine or formulate the hypothesis. Okay, then we will find the t statistics value. So now we will find the t statistics. Okay, so test statistics will be what? Test statistics will be what? T calculative value will be equal to x bar minus y bar by s into square root of 1 by n1 plus 1 by n2, right? Where s will be equal to what? Where s equal to s square equal to n1 S1 square plus N2 S2 square by N1 plus N2 minus 2. This can be written as summation xi minus x bar whole square plus summation yi minus y bar whole square by N1 plus N2 minus 2. Okay. So this is the formula to finding the test statistics for the equality of mean of two normal population when the sample size are small, right? Then then we'll determine, then we will identify level of significance, level of significance, significance alpha. Then from the t distribution table we will find, then step third we will find T alpha from T distribution table. T distribution table, right? T distribution table. Okay. So what things have to do? If the if keep in your mind, if it is one tail test, then we will find the value of T alpha by 2 comma n minus 1. But for in case of two tail test, we will find T alpha n minus 1. Okay. So this is the difference. If one tail test, then we will find the value of T alpha by 2 comma n minus 1 from the T distribution table. And if it is one two tail test, then we will find it T alpha comma n minus 1. Okay. So this is all about the step. Then now how can we determine the test? Again we use the same thing. If the T calculative value is less than T alpha, then it will accept the null hypothesis. And if T alpha is strictly greater than, sorry, T calculative value is strictly greater than T alpha, then we will reject the null hypothesis. Okay. So in case of two normal population, we find the critical value as a T alpha comma n1 plus n2 minus 2. That is, we will find the critical value T T alpha comma n1 plus n2 minus 2, right? And this can be found from the T distribution table. The alpha will be whole alpha for two tail test and it will be half for one tail test. Then mode of T calculative, if T calculative value is strictly less than T alpha comma n1 plus n2 minus 2, then it will accept H naught. And if T calculative value is greater than T alpha comma n1 plus n2 minus 2, it will reject. It will reject H naught. Okay. So now we will discuss a table, T distribution table. After that we will solve problem for the equality of mean of one normal population. Then we will discuss some problem based on the equality of mean of two normal population. So this is a T distribution table. You can see that for one tail test, if alpha equal to the 1, then in that case we will check for one tail test, this is as a T alpha equal to 0.5, that is T alpha by 2. And also this is the DF, that is n minus 1, and corresponding to that you have to find the value. Suppose that if you want to find the value as alpha equal to 0.05 for two tail test and n equal to the 9, so you will take this one 2.262, 2.262 will be taken. Why? Suppose that, how to see this table? Once again you can see that, suppose that alpha equal to 0.05, right, and n equal to the 10, so n minus 1 equal to what? 9. So you have to take the value from here, this value to this value. This is the point of intersection, right? So in this way you have to take the value of critical value of T from the T distribution table. Okay. So now in problem 1, in which manufacturer claim that the mean lifetime of its bulb is 1200. A random sample of 10 bulbs show a mean lifetime of 1150 hours with the standard deviation of 80 hours. test the claim at 5% significance level. You can see that the sample size is equal to 10, which is less than 30. So it is small sample size, right? In case of small sample size, we will use the t-test, okay, because the sample size is small. Okay, here claim is what? Claim is equal to 1200. As already we have discussed about that, if the claim is are given with equality, in that situation the problem will be two-tailed test, right? So now we will solve this problem step by step. Okay. So first what things have to do? First what things have to do? We will decide the hypothesis. Step 1. Hypothesis. Right? What will be hypothesis? H naught, in H naught, mu naught equal to what? 1200, right? So what will be the HA? Alternative hypothesis. Mu naught not equal to the 1200. This is two-tailed test. This is this is two-tailed test. Two-tailed test, right? Then we will find the in step 2 what things will we find? T statistics value, test statistics. For this, what is the value of x bar? X bar equal to what? 1150, right? And what is the value of sigma? Sigma, or you can say that S. This is not sigma. You can see the sample standard deviation. S is equal to the what? S is equal to 80, right? Alpha equal to what? 0.05. N equal to the what? 10. This is small n. This is 30. That's why this is the small sample size. So we will use the t-test, right? So test statistic in step. Test statistics will be what? Test statistics will be what? Test statistics will be what? T equal to x bar minus mu naught by s by square root of n. So this is equal to the what? This is equal to the 1150 minus 1200 by s is equal to the what? 80 by square root of 10. After calculation, this is equivalent to the minus 1.98, right? Now, what is the value of degree of freedom? df is equal to n minus 1, right? In step third, df, that is n minus 1 equal to what? N minus 1 is 9. So now we will find the critical value. So critical value, what is the value of t? Alpha 0.059. This is equal to the what? You can see that this is equal to the 2.262, right? So as we can see that the calculative value of this is what? T calculative value. So T mode of T calculative value. Mode of T calculative value is what? T calculative value is less than is equal to the T alpha n minus 1. So it will reject or accept. We can say that easily that as the calculative value of T is strictly less than T alpha comma n minus 1. That's why it will accept the null hypothesis. It will accept the null hypothesis H naught. Okay. So this is about the solution of first problem. What things we have done in this problem? First we will determine the hypothesis testing, then we will find the test statistic, that is T calculative value, then we take the value from the critical value T alpha comma n minus 1, that is T 0.059. This is nothing but 2.262, and we can see that the T calculative value is strictly less than T alpha n minus 1. That's why it will accept the null hypothesis. That means no significance difference from the claimed mean. Okay. So this is all about the first problem. Now we will discuss the second problem. Okay. Here nutrition claim that the average daily protein intake is 60 gram. A sample of 16 individuals shows a mean of 65 gram. with a standard deviation of 8 gram. Test the claim at 1% significance level, right? So now we will solve this problem step by step. Okay. So in step 1, hypothesis. Hypothesis H naught. H naught equal to what? In mu naught equal to 60, and H1 is what? H1 mu not equal to the 60, right? Because we know that the alternative hypothesis and null hypothesis are complement each other. Then in step 2, this is two-tail test. This is what? Two-tail. This is two-tail test. Why? Because the null hypothesis are with unequal condition. Two-tail test, right? So in step 2, we will find the test statistic value. Test statistics value. So this is t equal to 65 minus x bar is 65 minus 60 by what is the value of s? 80 by n, what is the value? 16, right? So this is equal to the what? This is 5 by 2, this is 2.5. Now what is the degree of freedom? We can find the degree of freedom is equal to the what? df. For step 3, we will find the critical value from the t distribution table. That's why it needs n minus 1. This is 16 minus 1 is what? 15, right? So we will find the value of what? T alpha equal to 0.01 n minus 1. N minus 1 is what? 15, right? So this is equal to the what? From the t distribution table we can find that this is equal to, for two-tail test, 2.947. We can find this from t distribution table. And since we can see that since the calculative value, t calculative value is equal to the what? 2.5, which is strictly less than t mod of t alpha n minus 1. So that's why this is, in this case it will accept the null hypothesis H naught. This means what? The no significance difference at the significance level 1%. Okay. So this is all about the problem based on the hypothesis testing for the mean of sample size less than 30. Okay. So now we will discuss about the equality of mean of, now we will discuss some problem based on the equality of mean of two normal population of small size. Okay. Now the next question, a group of 5 patients treated with a medicine A, weight 42, 39, 48, 16 and 41 kg. Second group of 7 patients from the same hospital treated with medicine B, weight 38, 42, 56, 64, 68, 69 and 62 kg. Do you agree with the claim that medicine B increases the weight significantly? So as we can say that here are two normal population are given, right? So we will solve this problem step by step. Okay. So in this question, what is the value of n1? N1 equal to the 5, right? What is the value of x bar? X bar equal to the summation xi by n1. This is equal to what? 230 by 5. Okay. So this is equal to what? 46. Now we will find the value of summation xi minus x bar whole square. So this is equal to the what? 290. Okay. So now we will find the value of s square. So s square equal to the what? So first we will then again we find the value of for n2 equal to 7, y bar equal to the what? Summation yi by n2. So this is equal to the what? 399 by 7. This is equal to the 57. Okay. So now again we will find the value of yi minus y bar whole square. This is equal to the 926. Okay. Now we will find the s square. So s square is equal to the what? Summation xi minus x bar whole square, x bar whole square plus summation yi minus y bar whole square. Okay, by n1 plus n2 minus 2. So this is equal to the what? This is equal to the 290 plus 926 by 5 plus 7 minus 2. So this is equal to 121.6. Okay. So now what is the value of S? What is the value of S? So S is equal to the what? S is equal to the 11.03. Okay. So now we determine the hypothesis. So null hypothesis. As the question claim is what? Median B is increased with the weight significantly. Okay, so the median B, that is, this talk about the mu2 is greater than mu1. So as claim is what? In the greater than form, that's why we first write the alternative hypothesis. First we will write the alternative hypothesis, then we write the null hypothesis. So this is will be equal to what? Mu1 is less than mu2. This is left tail test. This is left tail test. Okay. Now H note. H note is what? So H note is just a complement of this one. So we can write this one as a mu1 less than equal to the mu2. Okay. So now we will find the value of t calculative value. T calculative value. This is equal to the x bar minus y bar by s into square root of 1 by n1 plus 1 by n2. So this is equal to what? Minus 1.7. Okay. And alpha equal to the what? 0.05. So now we will find the value of t. Alpha is what? 0.05 comma n1 plus n2, n1 plus n2 minus 2. Okay. So this is equal to the 1.81, and this is for the one tail test. Why? Because you can say that this is the greater than type, so that is one tail test, and from the table we can find the value 1.81. So now add mode of t calculative value is strictly less than t alpha, so it will accept n1 plus n2 minus 2. It will accept h naught. Means what? Medicine A and B do not, means what? Medicine A and B do not differ significantly as their mean are equal. Okay. So now this is all about the equality of two mean for the two normal population for the small sample size. So now these are some problem for the practice. Random sample of specimen of coal from two mines from A and B were drawn. Their heat capacity was measured, yielding the following results. So this is all about the equality of two mean for the small sample size. So you will solve this problem. If you have any doubt or any problem, then you can comment in the YouTube link, right? Then now this is the final decision. Suppose we are conclusion my lecture based on the hypothesis testing, then what will be that? The final decision, the null hypothesis will be what? Presentation was useful, and the alternative hypothesis is what? Presentation was not useful, and test statistics is what? Audience feedback, and decision rule is what? If you learn something new, kindly accept the null hypothesis, and thank you for your, the conclusion is what? Thank you for your attention. Okay, thank you.